What if you could predict the future? In a way, that's exactly what we're talking about today. We're going to dive deep into the world of data science and see how we can turn all this chaotic digital noise into smart, intelligent decisions, all with a little help from a seriously powerful tool called TensorFlow.
Okay, just look at this number for a second. 2.5 quintillion. That's a 2.5 with 18 zeros after it. It's just staggering. And that's how many bytes of data we, as a planet, create every single day. Every Google search you make, every time you scroll social media, every mile you drive in a modern car, it's all feeding this massive, ever-growing digital ocean.
So, the big question is, what on earth do we do with all of it? I mean, the sheer volume is completely overwhelming. Your traditional software, it just can't keep up. It can't possibly sift through all that noise to find the important signals. This flood of data really demands a whole new way of thinking, and, well, a new kind of expert.
And that's where the data scientist comes in. But forget the image of a scientist in a lab coat surrounded by complex equations. It's much better to think of them as a modern-day detective. Their real job isn't just about the math, it's about investigation.
And this quote really nails it. Their mission, their whole purpose, is to dive headfirst into that ocean of data, start following the clues, and uncover the hidden patterns that no one else can see. They're basically looking for the story that the data is trying to tell.
So that's the real art of data science, right? It's all about turning that raw, messy information into genuinely useful insights. I mean, just think about Netflix. It analyzes everything you watch to perfectly suggest your next binge-worthy show. That's data science in action, solving the very real, very complex problem of what should I watch next?
But how do they actually do it? Well, it's not magic, even though it can feel like it. There's a process. Data scientists follow a pretty clear path to bring some order to all that chaos, to turn that raw data into something you can actually act on. So, let's break it down.
The whole process really boils down to 3 key stages. First up is data exploration. This is that initial detective work, poking around to understand the basic patterns. Second, and this is a big one, is data wrangling. This is the cleanup phase, fixing errors, dealing with missing values. It's not glamorous at all, but it is absolutely essential. And then finally, we get to the most exciting part, data modeling.
Okay, let's really get into this final step, because this is where the magic truly happens. Data modeling is where we actually build the brain, the prediction machine that learns from all that data to start making intelligent decisions all by itself. So, what exactly is a model anyway? Well, it's not like a normal computer program with a bunch of fixed rules. Instead, you show it thousands or even millions of examples, let's say pictures of cats, and it starts to learn for itself what a cat looks like. It's an algorithm that literally learns from experience, not just from a set of instructions.
And these models have evolved like crazy. The early ones, they worked by finding simple, predictable paths, kind of like drawing a straight line through a few data points to predict a trend. But today's problems? They are way more complex. So now we use things called neural networks, which are these incredible models designed to find super intricate patterns in millions of data points, kind of like how our own brains work.
But here's the thing. Building one of these complex neural networks from scratch is a massive, massive challenge. It takes deep expertise and just a huge amount of computing power. And that's exactly why data scientists and developers rely on these powerful toolkits or frameworks that do all the heavy lifting for them.
And right at the top of that toolkit is TensorFlow. It was developed by Google, and it's an open-source library that basically takes all the incredibly complex math behind neural networks and packages it up, making it actually feasible for developers all over the world to build really powerful AI.
So why is TensorFlow such a total game changer? Well, first, it makes building those multi-layer neural networks way simpler. Second, it's designed to handle what's called high-dimensional data. What that means is, instead of just looking at a customer's age and maybe their location, it can analyze thousands of data points at once, every single click, every view, every purchase. And by doing all that heavy lifting, it opens the door to deep learning for pretty much everyone.
And here's the coolest part. You already see models built with tools like TensorFlow every single day. The movie recommendations you get on Netflix, that amazing spam filter in your inbox that just works, the way your phone can automatically recognize your friends' faces in photos, yep, that's all powered by complex deep learning.
So we've seen how data has become this unbelievably valuable resource. We've met the data detectives who are mining it for clues, and we've looked at the incredible tools they're using to build these engines of prediction. It really just leaves us with one final, very exciting question to think about.
If data really is the new oil, what amazing things are we going to build with it next?